Bismillahirrahmanirrahim. Assalamualaikum to all students. Our topic now is 5.2 chain rule. Okay, Madam divide this topic into two parts, where the first one is the chain rule and the second one is the chain rule for power function. You can refer your book page 55. Okay, and okay, let me begin for the first part. Okay, first part, the chain rule. If y equal to fu and wait okay, y equal to fu and u equal to gx. Okay, we can see here we have two functions. Then the composite function, okay, meaning that we combine these two functions using composite function, become y equal to fgx, meaning that now we have here u, right, inside the f function, and we replacing u with gx, this one, okay, into the function. Okay, we replacing u equal to gx, and then this one, okay, makes the composite function y equal to fgx. Alright, I hope you understand. Okay, replacing u with gx since we have u here. And how can we differentiate the composite function? Okay, has the derivative given by, okay, dy, okay, since we have here y, dy over dx equal to dy over du multiply du over dx. Why? Because of, if we multiply, okay, meaning that you have to do step by step, where the first step you have to differentiate y, okay, differentiate y, where we have here the first function, and second step you have to differentiate u. Okay, alright, so I hope you understand. Okay, why? Because of when we differentiate these two and we combine, okay, why we, from where we get this formula, this one basically dy over dx equal to dy over du multiply du over dx. We can actually just simplify. Okay, that's why we get at the end dy over dx. Alright, so the step you have to differentiate y first, and then second followed by differentiate by u. Okay, so next I will explain to you how we solve this problem. Okay, example 1, find dy over du, du over dx, and dy over dx. Okay, remember the formula just now, but for this one you have to do step by step, where the first one you have to find dy over du. Okay, so now we have y equal to u power of 4 over 3. Differentiate this, what you get is 4 over 3. Okay, bring power to the front of u. 4 over 3 minus 1. So now we get here 4 over 3 u. Okay, 4 over 3 minus 1, you get 1 over 3. Alright, so this is the answer for dy over du. Okay, next you have to find du over dx, where the function is just this one, u equal to 3x square minus 1. Okay, differentiate this, you get 6x. Right, minus 1, differentiate that one, constant, you get 0. So to find dy over dx, what you have to do, remember the formula, dy over du multiply with du over dx. Just substitute, okay, this answer, these two, into the formula. So dy over du, we get here 4 over 3 u power of 1 over 3. Okay, multiply with du over dx, we get here 6x. Alright, so now class, you have to understand that, okay, the function now in terms of x. Okay, you cannot have x, okay, you cannot have u, sorry. Okay, now we have u mixed with x, right? So you have to make sure that all in terms of x. So just replacing u with in terms of x, we have now 3x square minus 1. Okay, 4 over 3, okay, u is equal to 3x square minus 1 power of 1 over 3. Right, and then multiply with If you confuse this one, just use bracket, or without bracket is okay. Since we have all multiplication, multiply with 6x. Alright, so this is the answer. See second example. You have to differentiate dy over du. Since this one you can see different division, you have to apply quotient rule. So to apply quotient rule, this is F and then this is G. Remember the formula. Dy over du, G F prime. Differentiate u plus 3, we get differentiate u, we get 1, right? Minus G F prime minus F G prime. F we have u plus 3. Differentiate G, we get, differentiate 3u, we get 3. Divide by G square, right? G square, we have here 3u square. Simplify this, what you get is 3u minus, remember, expand first, so we get here 3u plus 9 divide by 9u square. Simplify, 3u minus 3u minus 9 over 9u square. So 3u minus 3, you get 0. Negative 9 minus over negative 9 over 9u square. So we get here, simplify this one, we get negative 1 over u square. Alright, this is dy over du. And then to find x, so you have to differentiate dx over du. Since we have here 7 over negative u, so you have to bring it up, so there will be negative 7u power of negative 1. So differentiate this, what you get is, remember negative 7 is a constant. Bring negative 1 in front, and then u, negative 1 minus 1. So the answer now here, negative 7 minus negative 1, you get 7u power of negative 2. So means that you have to bring it down, so it will be 7 over u square. Now we already have these two, dy over du and dx over du. Now we write the formula to find dy over dx equal to dy over du multiply du over dx. Alright, so now we can see that dy over du we have here, and du over dx. Now we have dx over du, so you have to change this one into du over dx. There will be, you just switch this one, so there will be u square over 7. So you have to take this one to substitute into the function, right? Since this one in the function, we have du over dx. Substitute into the function. Now we have here dy over du, negative 1 over u square multiply with u square over 7. So now you can simplify. The answer is negative 1 over 7. That's all. This is the solution. So where you apply this formula. I hope you understand. Part 2, the chain rule for power function. Now we can see here we have a power of n, right? And the function we have fx equal to gx of n. So inside the bracket we have another function. So now to solve this, to differentiate this, you have to remember that it involves 4 steps. Just watch this. When we differentiate fx, what you have to do, first step, you have to bring n to the front. This is the first step. Second one, you have to copy all terms inside the bracket means, let's say the function is gx, you have to copy all, okay, meaning that let's say gx, you have here x minus 2, so you have to copy the same item in the bracket, so x minus 2. So now, okay, for the power, so you have to minus 1, alright, so this is the third step. And the last step, you have to differentiate all terms inside the bracket, meaning that you have to differentiate gx, so it become g prime x. Okay, to simplify this, okay, this is number 1, bring n to the front, and then number 2, you just copy all terms inside the bracket, and then number 3, you have to minus 1 for the power, and number 4, okay, so you have to differentiate terms inside the bracket. Okay, so I hope you remember these 4 steps. Okay, this is what we call chain rule for power function. Okay, now we have example 1. Differentiate hx equal to x squared plus x plus 1 power of 100. So we can see that this one you have to apply chain rule where we have a bracket. Okay, that bracket consists of many terms. Okay, this one considered as a function. Okay, function of, name it as gx, and then we have a power of 100. So now, okay, to apply this, you have to solve this, you have to remember the 4 steps just now. Okay, when we differentiate this, first step you have to bring 100 to the front, and then second step you have to copy all terms inside the bracket. Okay, third step you have to minus 1 for the exponent, for the power, and then the last step number 4, you have to differentiate all terms inside the bracket, meaning that you have to differentiate, name it as gx just now. So differentiate 2x, we get, differentiate x power of 2, we get 2x, differentiate x, we get 1, and differentiate plus 1, we get 0. So never mind, no need to write this. So to simplify this, the answer is 100 x squared plus x plus 1 power of 99, and then multiply 2x plus 1, right? That's all. This is what we call as chain rule. Okay, this is example 2. The question is fx equal to square root of x squared plus 1. Okay, remember we have now, dia panggil dia rumah lah. Okay, so now we change the pattern into, okay, tukar dalam bentuk macam ni, power of 1 over 2. So now we can see that now we have inside the bracket, we have terms, right? So considered as gx. Okay, differentiate this. Remember the 4 step just now we discussed. So bring 1 over 2 to the front, copy all terms inside the bracket, and then the power you have to minus 1, and then next, the last one, you have to differentiate all terms inside the bracket. So we get here, differentiate x power of 2, get 2x plus 0, right? Okay, no need to write. So simplify this, we get here 1 over 2 multiply x plus 1, okay, and then the power we get here negative 1 over 2, okay, because of 1 over 2 minus 1, multiply 2x, right? And normally in the question ask you do not simplify, right? But never mind, we try. Okay, for this one, okay, let's say the question asks you do not simplify. Okay, just leave it till this part, alright? Okay, now but for now medium saja je nak solve. Okay, let's say ni kita boleh solve, alright? So jawapan akhir dia akan jadi, because of kita ada negative exponent, dia akan jadi x ke atas divide by x power of 2 plus 1 power of half. That's all. This is the solution where tak perlu pun buat sebenarnya, alright? Now we have here example 3. Okay, fx equal to x square multiply 2x plus 3 power 5. So we can see here we have product rule, because of now we have this one f and all of this term is g. Okay, so inside the product rule you have chain rule, right? So to solve this, you have to solve one by one, alright? So if we differentiate f prime x, remember the formula for the chain rule, product rule. So f g prime plus g f prime, right? So just use this formula to solve this. Okay, f we have here x square. Okay, g prime. Okay, g prime, remember g prime all this function including 5. So you have to apply chain rule. Okay, so bring 5 to the front, and then 2x plus 3. Okay, copy all terms inside the bracket, and then power you have to deduct by 1, tinggal 4, and then differentiate terms inside the bracket, so we get here 2 only, right? Because of 2x we get 2, 3 we get 0, plus, okay, g 2x plus 3 power 5, and then f prime differentiate x square, so we get here 2x, right? So simplify this. Okay, so we get here x square multiply 5 multiply 2, we get here 10x square, 2x plus 3 power 4 plus 2x. Okay, just bring it in front, and then 2x plus 3 power of 5. Right? Okay, that's all. This is how we solve the function that involves chain rule in the product rule. Alright. This example number 4, last example. Okay, fx equal to 2x plus 1 divided by 3x plus 2 power of 2. So now inside okay, for this function, okay, we can see here we have to apply 2 rules. Okay, where the first one we can see here we have rule number 1, chain rule, and number 2, inside the chain rule we have quotient rule, right? So we have to solve one by one. Okay, for chain rule, remember when we differentiate fx, you have to bring 2 to the front, copy all terms inside the bracket, plus 2. Power we have to deduct 1, so 2 minus 1 we get 1, right? No need to write. So next we have to differentiate all terms inside the bracket. So since we have here division, you have to apply quotient rule. Okay, so apply quotient rule, you have to use okay, open square bracket, and the formula is g. Okay, copy g 3x plus 2, f prime differentiate 2x plus 1, we get 2 minus, okay, g f prime f 2x plus 1, and then differentiate 3x plus 2, okay, g prime we get 3, okay, divide by g square, so 3x plus 2 square, right? So simplify all of this, we get here 2x plus 1 divided by 3x plus 2, and then inside the square bracket, so we have here 2 3x plus 2 minus 3 2x plus 1 divided by 3x plus 2 square. Alright, okay, that's all. This is the answer where inside the chain rule we have quotient rule. Okay.